When we change the temperature for a resistance, the resistance will also be changed. We have three formulas to find out the resistance if we change the temperature. The book has the upper formula where basic is that the resistance that we know is at a temperature of 0 degrees. The next formula is based on that we have a resistance, a known resistance at a temperature of 20 degrees. And the last one is not based on any temperature at all. I like the middle formula because I think 20 degrees Celsius is the normal temperature for a given material. But we can use all the formula. The formula says that the resistance at a new temperature is the basic resistance multiplied by 1 plus alpha multiplied by T minus 20. Alpha is the temperature coefficient and it depends on the material for the resistance. So, for example, down here we can see alpha for copper at 20 degrees Celsius is 0.004 per degree Celsius. We can see that alpha is also depending on the temperature because alpha for copper at 0 degree is 0.0243 per degree Celsius. So the value for alpha will change by the temperature. Normally we don't take care of that. We just use the value in a given temperature range. But we should know that if the range of the temperature is very high, maybe this formula is not allowed because alpha will change too much. But for the assignment, we'll use this formula and the value for copper, for example, 0.004 and aluminium 0.0037, and I think we'll get the correct result. The lower formula is seen in many formula books, and it's not quite correct to use that. This one is better or the other one, but I think it's okay to use it. You just have that the resistance for a new temperature is the resistance for the reference temperature multiplied by 1 plus alpha multiplied by the new temperature minus the reference temperature. If we use this formula instead of this one, it'll get a minor error, but I think it's okay. It's just a slight difference. Maybe you have seen this formula before, and here we calculate the new resistance for a given material or resistance. You also have used this formula or this type of formula if we have to calculate the length of a given material if we change the temperature. You also use alpha, but remember that this alpha is very different from the alpha if we have to calculate the new length of a material. So remember to use the temperature coefficient alpha in this formula.